Section 8.6 is on solving rational equations. Solving rational equations. So we are asked to solve 5 over 2x minus 2 is equal to 15 over x squared minus 1. This one we have a fraction is equal to a fraction. And there's a couple ways you could take care of this. In the past, when you've had a fraction is equal to a fraction, you cross multiply, you do 15 times this is equal to 5 times that. And that will work fine. The equation that you'll get will be a little more difficult to solve than the way that we're getting ready to do it. Also, if you do it this way, you do need to check for extraneous solutions, which we'll check for anyway, but it's more likely that you'll get extraneous solutions if you do it this way. If you work through all this and you solve and you eventually get x equals 1, when you plug x equals 1 back in, notice I get 5 divided by 0. 5 divided by 0 is undefined. So we do not list x equals 1 as one of the solutions. So that'll get us to the better way to solve this. 5 over 2x minus 2 is equal to 15 over x squared minus 1. We're going to start by factoring all of our denominators. So 2x minus 2, I can take a 2 out. X squared minus 1, I can factor to x plus 1 and x minus 1. And then we're going to take a look at all the denominators. 2 times x minus 1, x plus 1 times x minus 1. And we are going to find the least common multiple of all the denominators. So our LCM, we've done it over the last couple class periods, is going to be 2 times x minus 1 times x plus 1. We need 2x minus 1, 2 times x minus 1. We need x plus 1 times x minus 1 with nothing extra in there. And we are then going to multiply both sides of our equation by the least common multiple. So I multiply this side by the LCM. I also multiply this side by the LCM. Got my equal sign right here. And when we do that, notice some things cancel out here. X minus 1s cancel. X plus 1s on this side cancel. So this side I just get 30. Here my 2's cancel. My x minus 1's cancel. And on this side I have 5 times x plus 1. Notice once we get down to here, this is a very easy linear equation to solve. Notice if we had done what we had talked about previously where we cross multiplied, notice I get 5x squared. I get a quadratic equation. Quadratics are a little bit more difficult to solve than linear equations. Anyway, distribute your 5 and finish solving. I get x equals 5. Not a bad idea to check your solution. The only way you should ever get extraneous solutions is if it makes you divide by 0. Plugging in 5 here gives me 5 over 8 equals 15 over 24. And notice those fractions are equivalent to each other. If I divide the top and the bottom by 3, you get the same thing. It does indeed check x equals 5. Example 2 asks us to solve 4 over x minus 3 over x plus 1 is equal to 1. 4 over x minus 3 over x plus 1 equals 1. If we were doing the cross multiply method, notice we would have to simplify this first. Multiplying both sides by the least common multiple, we do not need to start by subtracting these fractions. So our LCM of the denominators is just going to be x times x plus 1. So we multiply both sides of our equation by that least common multiple. So this side times x plus 1, and this side times x plus 1. So this side over here, I'm just going to distribute this 1x. I just get x squared plus x. On the left, when I distribute this, I've got x plus 1 times this. So 4x times x plus 1 over x. I've got x plus 1 times this. 3x times x plus 1 over x plus 1. And as long as we multiply by the LCM, all of our denominators should cancel out. So here, x divided by x cancels. X plus 1 divided by x plus 1 cancels. So I have 4 times x plus 1. Let's distribute that 4. Minus 3x equals x squared plus x. Combine like terms. Get our equation equal to 0. Minus x, those cancel. Now you've got options. You could solve by square roots because we don't have any x's. You could bring the 4 over and square root both sides. Or you could factor, that's a difference of squares. And we get x equals 2 or x equals negative 2. Again, it's smart to check. Plugging in 2 gives me 4 divided by 2. Minus 3 divided by 3. That one checks. Plugging in negative 2, I get negative 2 minus negative 3 divided by negative 2. Sorry, 3 divided by negative 1. And that one checks. Again, it should. The only reason it would not check is if it makes you divide by 0. Example 3. 11 over 3x minus 1/3 equals negative 4 over x squared. 11 over 3x minus 1/3 is equal to negative 4 over x squared. Our LCM, I need 3. Here I have an x. Here I don't have any x's. Here I have x squared. The biggest one is x squared. 3x squared should be our least common multiple. That's what we're multiplying both sides by. This side gives me negative 12x squared divided by x squared. And those x squareds cancel out. Distributing 33x squared over 3x minus 3x squared over 3 x squared over x is x. I get 11x minus x squared equals negative 12. We've got a quadratic equation. We solve quadratics by getting them equal to 0. And factoring them. Set each factor equal to 0. We get x equals 12. X equals negative 1. Notice neither of those make us divide by 0, so we do not have any extraneous solutions. Those are our answers. Example 4 looks pretty awful here. We've got 4 over x plus 6 over x plus 1 all over 3 over x plus 1 minus 5 is equal to negative 1. Again, lots of different ways that you could solve this. We could simplify this complex fraction here on the left side, and then cross multiply or do what we did today. I think probably the easiest thing to do, I've got something divided by something else equals negative 1. Let's just multiply both sides by this thing here. So those cancel. So I'm multiplying this side by 3 over x plus 1 minus 5. That gives us 4 over x plus 6 over x plus 1 equals, distribute this negative 1. So negative 3 over x plus 1 plus 5. And now it looks a lot like the ones we've done today. The least common multiple, I've got x plus 1 in my denominators. My LCM should be x times x plus 1. If I multiply the left by that, I multiply the right by the same thing. Distribute. Whoops. That's not an equal sign, that's plus sign. So I distribute the x and x plus 1 to each of the terms. All of our denominators should cancel. So my x's cancel here, my x plus 1's cancel, my x plus 1's cancel. I'm going to distribute this 4. And distribute this 5x. Combine like terms. And get our equation equal to 0. We've got a quadratic. We solve quadratics by factoring and setting each factor equal to 0. 5 times negative 4 is negative 20. We need numbers that multiply to negative 20 and add up to negative 8. It'd be negative 10 and positive 2. And take a 5x out of the first two terms, a 2 out of the last two terms. So my factors are x minus 2 times 5x plus 2. Set each factor equal to 0. And solve. I get x equals 2, x equals negative 2 over 5. Neither of which make us divide by 0 anywhere. So both check. Last one, example 5. I want you to try this one. Solve this rational equation. So pause the video, you try it. Once you think you have it, you can restart the video. I'll show you the solution. We're going to start by factoring everything. The LCM is 2 times x plus 1 times x minus 1. So I get 6 times x plus 1 times x minus 1 over x plus 1. Distribute here. And all of our denominators cancel out. Distributing the 6, I get 6x minus 6 equals x plus 1. Notice I have minus this x minus 1. Make sure you distribute the minus sign. So this is minus x minus negative 1. Two is 6x minus 6. 8 over 6 or 4 over 3. That is all for today's notes. Make sure you reach out if you do have any questions.